The topic of our discussion in these lectures is the file systems. The file systems is a module in the operating system which takes care of information management at the basic level. When we say that it's information, we mean here the programs. It may be application programs, it may be operating system programs, and the data that are used by these programs. The file system consists of two parts. One, naturally, is a collection of files, and the other is a directory structure which takes care and keeps track of these files. Now, let us see that when we say a file, what actually and exactly we mean. First, let us see what is a record. The record is a collection of related fields. For example, say if we take the student's record, it will consist of many fields: the student's name, his date of birth, say, then his address, the subjects he has taken, the grades he has scored, the overall grade, his registration number, and so on. Each one is a field, and the collection of these fields constitute the student record. Now, the record may consist of only, say, one field. So, for example, when you talk about a matrix, the ijth element, that any element in the matrix, is essentially a floating point number, say, and therefore the record here consists of only one field, which is a floating point number. Now, on the file is a named collections of these related records, and the smallest allotment of secondary storage to users, okay, which means the file systems, as far as users is concerned, will give spaces in terms of the file, okay, or the file sizes, right? Now, let us see what are the functions of the file system. The functions of the file systems are that it does online storage and retrieval of information, and this information may belong to the operating systems, other systems programs, or of users, okay? And file systems also provide a uniform logical view of information storage, irrespective of the exact device being used. It may be, say, magnetic hard disk, floppy disk, it may be optical disk, or it may be, say, magnetic tape. Of course, in this lecture, we'll assume that we are dealing with magnetic disks. Now, when you say that file system, as I say, that we'll take it is a logical device where information is stored. Okay, just mark the word that we take it to be a logical device, and it consists of, as I say, it is a collection of files and a directory structure which keeps track of all these files. Now, the management routines in the operating systems maps this logical device into physical devices like, say, magnetic hard disk, okay, or magnetic floppy disk, etc. Now, we come to the file attributes. The different attributes a file has, naturally, it has to have a name, it has to have a type. What type it is, we'll see, we'll elaborate on it subsequently. The location of the file in the secondary storage, the size of it, okay, time and date. And when we talk about time and date, the different times and dates may be there. For example, it can be the time and date of creation. It can be the time and date of the last access. It can be the time and date of the last modifications, etc. And all these informations can be kept, okay? User identification is naturally another parameter, attribute that has to be there. For example, who is the creator, who all can use it, use this file, etc. Now, let us come to the file types, which is an important parameter, okay? Generally, the file types we keep as a dot followed by an extension. So, file name, dot followed by an extension. The types may be that executable. Generally, the extension used for this is exe, bin, or we do not give any extension, meaning that it's an executable file, right? It can be a source code. So, for example, in a C program, 1477 program, a Pascal program, or an assembly language program. It can be an object file, okay, generated after translation, okay, and extension used maybe obj or o. It may be a text file, extension used text and doc, okay. It may be a batch file. By batch file, we mean that it's a file of operating system commands, okay, generally represented by bat or sh shell, okay. It can be a print file or a view file to be seen on a screen, right? Video screen, and the extension that are used are say PS, PostScript file or DVI file, or it can be an archival file kept for archival purposes, and the extension that are used may be zip, tar, or arc generally, okay? Now, the different file operations that are permitted generally are create, that means to create a new file, delete an existing file, read from a file, write into a file, read a record from a file naturally, write into a file, append a file, okay, to an existing file, right? That means the existing file is appended by adding more informations into it. Seeking a file, that means in a directory structure, in the total file systems, that whether a file is there, if the file is there, where it is, and then open a file to some operations like read write, and close a file that after the operations is over, okay, close it down, that this file is no more needed, okay. Now these are the file operation. The file accesses that we consider here generally are sequential access. That means read next in a file, read the next record, write into the next record, okay, write the next record into the file, and reset it. That means bring the reading or writing to the beginning of the file, okay. That means the pointer, bring it back to the beginning of the file, okay. Now also we use direct access. Here n is the record number, and we say that read the nth record, write the nth record, okay, or sometimes we say that position the head, okay, that means our pointer at the nth record on the file, and then go on read next or write next, and rewrite n, that means nth record is modified and rewritten, okay. These are the file accesses we will generally consider, okay, and are the general file accesses so far as our file systems are concerned. Now to keep track of these files, okay, we define a directory structure, or we make a directory structure. The directory structure may be single level directory structure. For example, here I have shown a single level directory structure. This is a directory. Here are the names of the files, right? So example, test is a file. Here's the location, that means where the file exists. How the location is defined, we'll see subsequently. So example, here's a test file, right? I've shown the files, say, as a rectangle, green rectangle here. Matrix is a file, then bin is a file, okay? All of them are files, and this is the directory. Now, if we know the directory address, and in that case, by knowing the name of the file, we can come to the corresponding entry in the directory, and then from here, since the location is known, we can go to the file and start retrieving information from the file, or start writing information, records into the file, okay. This is a single level directory structure. Naturally, a single level directory structure has some limitations, okay. What are the limitations will be apparent as we discuss, okay, and come to what we call, say, a tree directory structure. Here you see that these rectangular boxes that we represent directories, and the green small circles we represent the files, okay. By green circles represent the files, and by this pink, the rectangles, we represent the directories. You see, here is a directory, right? Like say the directory here. Okay. Now this directory, under it has 3 directories. Okay, we call them subdirectories. Okay, therefore this directory has 3 subdirectories. One of the subdirectories, say this one, has 2 files under it. Okay, and another subdirectory under it. And this subdirectory has another subdirectory under it and a file under it. And this subdirectory has 2 files under it. Okay. Now you can see here that way. For example, here is another substructure. Here is another substructure. And if you see it, you see that this is essentially a tree structure. Okay, and the directory structure here is a tree structure. Okay. Now this tree structure has several advantages. We see what is the advantages. Firstly, naturally, that we can group. Okay, so for example, here we can group the files of a particular person to be used, or a particular group to be used under one directory. Right? There will be some more such advantages which we'll elaborate as we proceed. So here I've shown a tree structure. Okay, you see that here is a directory. Okay, this directory consists of several entries. Okay, that users, libraries, LIBR, games, system, application, and others. Okay, now each one of them is a directory. For example, users is a directory which possibly, okay, that keeps track of or keeps under it all the users of the system. Like, for example, say Munia is a user, Partho is a user, Batch 1 is a user, UG4, for example, undergraduate students of the 4th year level is a group of users, right? Now, all of them are users, and all of them possibly will have a directory. For example, say this Munia has a directory, say, containing 3 elements. One is a documents, okay, another is a games, another is a programs, right? And say this documents is a directory which consists of 1, 2, and 3 directories and 2 files. The green ones I've shown as a file, and the black entries are the directories. For example, the letter is a file which points to this file. Okay. Now, this way you can see that here is another substructure, right? Here starts another substructure. Therefore, this is a directory structure, okay, which is a tree structure directory. Here is the root of the tree. We call this as a root. They are the internal nodes. All the leaves of these roots are files, okay? The internal nodes are the directories, and they may contain either a subdirectory or a file, okay, as has been shown over here. Now, for example, if you want to name, or if you want to approach, okay, this file later, starting from the root, it has a unique path name, okay, and the unique path name, you can see, we can write it this way. So, for example, say this is the root of it, then this is go to, say, users, right? This is the users directory. Then say we go to the directory. This is the directory Munia, okay? Then we go to the say directory documents, right? Then we come to, when we come to the document, this is a directory, and if we want to go to this, for example, this particular file, then we say, okay, this we call a path, right? Starting from the root to a particular file or to a particular, say, for example, if we come here, we want to come here to this directory, okay? Instead of later, we can say that this remains same. We say office, then we come to this subdirectory, right? Now, this is, we call a path, and this is called an absolute path. Absolute path means starting from the root, we are saying a path by which we can reach a particular file or a particular subdirectory. It's called an absolute path, right? Now, sometimes we can talk about a relative path where we can define, say, a working directory of a particular user. For example, for the case of a Munia, the working directory of Munia can be this the subdirectory, okay, and therefore whenever she logs on into this directory automatically, and therefore his relative path name for the later will be simply, okay, right, when this is his working, sorry, this is her working directory, right? Therefore, the path name can be either absolute, that means I start from the root, come to this file or to this directory. Another is that it can be relative in the sense that it has a present working directory. From here, he or she specifies that where to go, okay, by specifying a path name. Here, the path name is simple later because immediately, okay, she comes to this later file, and once in the later file, she can retrieve the records in this later. Okay. Now see, what are the properties of the tree structure directories? One is naturally that we can have an efficient searching in the case of a tree structure directory. We can have the tree search starting from the root. We can come over to any of the subdirectories or any of the files, right? Second important property is that capability of grouping. For example, here you see that the capability of grouping, we have done, so for example, all the users have been kept under the users, okay? All the files and the subdirectories of Munia have been kept under this subdirectory, which is essentially the root of a subtree, okay, at this point, right? Essentially, this is the root of a subtree, okay, positioned at this point. Let's come to here that all these subdirectories, that intermediate nodes, are essentially the roots of the subtree. For example, this is a root of this subtree, this is a root of this subtree. Therefore, whenever someone is here, for example, he or she can access any of the information that is kept under this subtree. Similarly, if someone is here, he or she has to his possession, okay, or to his control, okay, I mean to his access, anything that is under this subtree, okay, by means of specifying a relative path. Of course, he or she can move to the root and access any of the subdirectories or the files, okay, that are permissible to be accessed by that particular user, right? Now, this is therefore, we are talking about that capability of grouping. We can group them, for example, here that applications have been grouped here under the different areas like say electrical engineering, civil engineering, mechanical engineering, and under that electrical engineering we have a sub directory. Under civil we will have one, under mechanical we will have one, and so on. Therefore, you see that capability of grouping immediately gives us the facility of grouping, say that like users or like applications under a subdirectory, and therefore all the files underneath, okay, under that subdirectory or under that subtree. Now we can also, as I say, that we can specify a current or working directory. For example, we can, as I said, that we can specify a current working directory, current directory, or present working directory of Monia to be this one. So, for example, for applications under E, electrical engineering, we may specify the current working directory to be this one, and so on, right? And the path name we can specify to go to any particular subdirectory or to any particular file, and the path name is unique. Okay, the path name is unique. We can see either it's an absolute path name, or we can speak in terms of a relative path name. Okay, as I've already explained, right? Now, let us come to the operations that we can do on such a file system. We can create a new file, we can create a new directory. Okay, all new file of the new directory will be created in the directory which is a present working directory, right? Similarly, you can delete a file or you can delete a directory as well. Okay. Now, so long we had been talking about the directory structure, which is a tree. Okay. Now let us see that if we try to break away from a tree, okay, and say have an acyclic graph directories, now what are the benefits that we can have? Okay, the benefits that we can have is that the files and subdirectories can be shared, okay, and aliasing is possible. Let us see what we mean by it, right? So, for example, here is a tree, right, and what we do is this. Here we create a link from this subdirectory to this subdirectory. You can immediately see that our tree structure is broken. Okay, that we have violated the definitions of a tree, and now it is a graph, but it's an acyclic graph. There's no cycle in it. What happens actually that under this subdirectory, therefore, by just creating this link, whatever is there within this subtree comes under the purview of this subdirectory, right? Therefore, what we can do is that this subdirectory can be, I'm sharing the subdirectory. The subdirectory is being shared by this directory as well as by this directory, both of which are subdirectories of this root directory. Okay. Another thing, for example, can be done. Say, here is a file, and I create a link, say from here to here, okay, which means this file is now shared by this subdirectory and also by this subdirectory, meaning thereby, say, any user group which was, or an user who was using it and possibly created it, he can give this file to be shared by another user group or by another user. Okay, therefore, this is what we mean when we say that files and subdirectories can be shared if we go for an acyclic graph directories, and that aliasing is possible. By aliasing means, say, this particular file now has an absolute path name like this, okay, and an absolute path name by this, okay. Therefore, you see this particular this particular file has two names in terms of its say the absolute path name, and so also that if we create a different name here, this will have a different relative name with respect to these two users, right? Therefore, you see that we have that aliasing possible. Let us see, say, to come to this particular example. Here, say this particular file, this was under that application under electrical engineering, and say it's a finite element methods program which was being used by electrical engineering department. Okay, this is a file, and say that mechanical engineering department, okay, or those people wants to share this file, right, and have the permission to share it from the original creator that electrical engineering people. Therefore, what can be done is this, that say a link from here can be created from this subdirectory to this file. Okay, this link FE is being created, okay, by a command. Such commands are available, right? Therefore, you see this particular file is finite. Okay, the relative name is, the file name is finite for electrical engineering, right? And the file name is FE for the mechanical engineering people. Therefore, if you are in this directory, you access it by FE. If you are in this directory, if you access by finite. Similarly, naturally, from the root, if you take the path, right, in that case, the absolute path name will be different for this file, depending upon which way you go, either this way or you go by this way. Similarly, so for example, say this particular subdirectory, which is a matrix under electrical engineering, can be shared by mechanical engineering by creating a link, say mat, into this subdirectory. Then everything that is available here are available as a mat here, right, and a matrix from here, right? That is what we call by sharing subdirectories, right, and aliasing. Okay. One more things that I think that I should clarify, I should explain is this. So, for example, similarly, different files or different directories can be given the same name. Just think of a situation that games, okay, in this subdirectory, which is possessed by Munia, and the games, which is the subdirectory in the subdirectory possessed by, say, Partho, may be two different files or subdirectories altogether, given the same name. Both has the names games. Here it is also games. But you see, if you take an absolute path or relative path, okay, these two are different, and therefore the games of Munia is different from the games of Partho. But if we wish, we could have made the same game subdirectory pointed to from here as well as here by sharing games. In fact, here you see there is a games. This also can point to either the same subdirectory or it can point to a different subdirectory. Therefore, you know that this gives us quite a flexibility in grouping as well as usage of subdirectories and files. Okay. Now let us see what can be the problems if we do it. Okay. The problem is a dangling pointer on deletion. Let us see what we do when we delete it, right? When you delete a file, for example, say, let us take this structure. So, for example, if we want to delete a file, we simply delete it and therefore it's no more exist, right? For example, if we want to delete a directory, this directory if we want to delete, generally what is required is that all files or under it should be first deleted, okay? All files and subdirectories under it should be first deleted, only then it can be deleted. For example, if you want to delete this one, everything has to be deleted under it, okay, before you can delete this one, right? Now, say for example, if we want to delete, say, this particular entry in this subdirectory, you delete it, right? But you cannot delete everything over here because there is a pointer from this, and therefore to keep track of it, we can keep a reference count, okay, that how many pointers are there pointed to this subdirectory or this file. For example, say take the question of this file. Say if you delete, say for example, the user here deletes this one, then this link is gone, right? So this link is gone, but this link still exists, and therefore this particular file cannot be deleted until and unless this link is also deleted. That means the user here deletes this file. Therefore, reference count, say 2 is kept over to here. When this user deletes it, the reference count is made to 1. And when this user deletes it, then the reference count is made to 0. And when the reference count is 0, only then this file can be deleted. Okay. Because on deletion, if you simply delete it, on deletion of this link, if you simply delete it, then there will be a dangling link, okay, which naturally will create a whole lot of problems. Okay, therefore this is the methodology that is generally adopted when we delete a file or say delete a subdirectory. And as I said, that a subdirectory can only be deleted if all the files and subdirectory under it, okay, are deleted. That means there is no files or no subdirectory under that subdirectory. Now, but this may create some problems. What the problems of this graph is, let us come to. Okay, now we have been talking about that acyclic graph. So, okay, right. For example, here also I have shown a directory structure, right? Okay, which itself is an now as such is an acyclic graph. Okay, now what we do is this, that we go on basically adding links. For example, here or here, we went on adding links, okay, to come to acyclic graph directory from the tree structure, right? Now, who prevents to create a link, right, such that a cycle comes into the picture? For example, say I create a link from here to here. The moment I have created that link, you can see immediately that I have created a cycle. And as soon as I have created a cycle within this graph, there are many problems that immediately may crop up. Firstly, for example, say that if we start searching for a particular file, and if we are not careful, then we can be, okay, in an infinite loop like this, and therefore we'll have to be careful when we search a tree, okay, sorry, search a graph which has a cycle, okay. And another problem will crop up. What's the problem will crop up? We'll see, okay. Now, think of a situation, therefore, that we have created a link which has made a particular directory structure which was acyclic, now has turned out to be cyclic. Now, what to do? The point is better not to have cycles. Okay, many operating systems, for example, Unix, okay, when you create a link, naturally the link can be created only with the permission of the root user, that means the system manager, and at the time of creating this link, it is checked that whether a cycle is there or not. Okay, cycle is being created or not, and if a cycle is being created, okay, it is prevented generally in such implementation, right? And you can see, though the checking that whether in a graph a cycle is there or not is the time complexity is linear, but implementing it at the backup, I mean the second, sorry, not backup, the secondary storage is quite time consuming, and therefore it should be, okay, it should be what to say that it's better if we can prevent such creation. And the other problem, as we have said, that when we are dealing with, for example, the searching a particular file, okay, that we'll have to be very careful if we allow such creation of loop at all. If we allow such creation of loop at all, in that case, that searching for a particular file, one has to see that one does not get entangled in an infinite loop. Okay. Now, there can be some other problem here. Okay, that when we deal with that general graph, okay, and that is that creating that when you delete it, deletion may not be possible even for unreachable nodes due to reference count, say, being non-zero. For example, let's see what do you mean by this. Here we say that that deletion may not be possible even for unreachable nodes. Let us see what the situation. See, for example, we have created, instead of this loop, we have created a loop like this, or say from here a loop like this, right? Now you see, suppose that we have now deleted this link, right? That means the original link from here to this subdirectory has been deleted. You can see now the reference count here is, say, minus this one is there or this one is there. Therefore, I'm saying, or maybe both may be there. The reference count was, say, 1, 2, and 3. Therefore, the reference count is, say, 3 here. We have deleted this one. The reference count now is 2. But you see, this particular subtree is not reachable at all. From nowhere, we can reach this subtree. And so, though the reference count is non-zero, right, and therefore we cannot delete the subtree. The subtree remains, but it's an unreachable subtree. Okay, that is exactly what we're trying to mean when we say the deletion may not be possible even for unreachable node. Okay, here these are unreachable nodes. We cannot delete them because the reference count is not 0, and therefore this is occupying secondary storage spaces, and we cannot delete it until and unless a very carefully planned garbage collection routine checks, okay, that these are nodes which are unreachable, right? Now, let's see, therefore, here we summarize what we have said here, that in the case of a general graph directory, that adding a new file or a directory to a tree structure maintains a structure. Okay. For example, that if we add, say here, a file, or say here, say a directory, right? The original tree structure remains. Okay. I mean, it's better to show by this example. Say this was not there, okay, and say this was not there, these two are not there. Say I want to add a file here, the original tree structure remains. So for example, I want to add a subdirectory here, right? A tree structure remains. Assume that this link and this link is not there. Therefore, that is exactly what we mean when we say that adding a new file or directories to a tree structure maintains a structure. Okay? But adding links to an existing tree, structure is destroyed. For example, as we are adding links to the existing structure, this we call link. Okay? Originally, this subtree, the subdirectory was there, this file was there, we are simply adding it, and therefore the tree structure is destroyed. And here it turns out to be acyclic, okay, graph structure, and it may further destroy the acyclic nature if the link that I add, okay, may create a cycle. Therefore, the acyclic nature of the graph may also be destroyed. Okay, and here we say that what are the problems in the case of a acyclic, cyclic graph, right? Now the next question turns out to be that what's the protection that we have to take once the files are created, right? The different types of protection that we can take are the access types we declare. The access types can be read, okay, it can be write, it can be execute, okay, that means it can be read only, one can be allowed to read it, one can be allowed to write a particular file or subdirectory, one can be allowed to execute a file, one can append to an existing file, okay, one can delete a file or a subdirectory, or one can be allowed to, okay, release the content of a file or a subdirectory. Now the access control naturally, okay, will be controlled by the owner, that is the creator of the file or the subdirectory, that what can be done or by whom, okay, this access can be permitted, right? One method can be that we attach a access control list or a matrix, okay. For example, by access control list we mean they give a list of all the users which are allowed accesses and the type of accesses. For example, that user 1 may allow a particular file, okay, file name is to read it and execute it, but not write it, okay, or not append it or delete it, right? Therefore, we can attach a access control list to a particular file or a subdirectory, or we can attach a matrix also. In the case of a matrix, what is done is this, that you create a matrix like this. Here you have all the users and say here all the files or the subdirectories, okay. Now for a particular user, okay, say Partho and a particular file, say Matt, you tell here, you specify here the type of accesses that is permitted, okay, for Partho, okay, to use Matt, right? That it may be read only, read write, execute only, delete, or say for example append, etc. All such permissions are enlisted here, okay. Now, but problem with such a situation is this, right, that naturally the matrix turns out to be too huge and maintenance also turns out to be quite problematic, and therefore what can be done is this, that you specify what we call that an access mode, okay. That means whether read is permitted, write is permitted, or execute is permitted, R, W, and X, okay. And you define that user categories, okay. That owner is a category who has created it, group is a category, and public is a category, and you define the accesses permitted to the owner, to the group, or to the public. This is the angle, okay, or the view taken by Unix operating systems. For example, that owner read, write, execute may be all one, say 1, 1, 1, which means 7 means owner can read, write, or execute. Group possibly, right, say can read, say not write, but can execute, okay, therefore 5, right? 5 means the group can read it or execute it, but can't write it, and the public, okay, which is not, who is not a owner or who is not a group, say possibly is given only execute only, therefore its access type is 1, okay, or access value is 1. Now, system manager, what it does that it creates a group and adds user to it, naturally on the request of the owner, okay, system manager creates a group and adds user to it to create that group, and then one can define an appropriate access. For example, for a particular file name, by means of, in the case of a Unix, chmod command, if you say 761, 7 is for the owner. Here, group is 6, which means he can read, he can write, possibly, but he cannot execute, right? And this is 1. 1 means for the public, that means you can execute only, right? Therefore, we can execute this command chmod in Unix, okay, give the permission, the access capability of the owner, group, or the public, right, followed by a file name or the directory name, and that particular access control will be associated with that file name or with the directory name, right? And after that, you attach a group to a file, right? For example, you can attach a group to a particular file name by this way, that ch group name to file name. Therefore, what you should do is that you should create a group, attach a group to a file name, and for a particular file, you declare what kind of access you want to permit to yourself, that means the owner, to the group or to the general public, right? That's the way that Unix handles this access control, and this is quite a nice way of handling the access control, okay? Naturally, I hope by this time you have come across this and you have used these commands also. Now, last of all, let me define what we call by partition. Now, so example, if the entire number of files or the number of directories is too huge, okay, to manage such huge data and the file system, what we do is that the file system itself is broken into partitions, okay? That partition sometimes is called a mini disk or sometimes is called volumes. This is done to handle huge volumes of data as well as directories, right? Now, once the file system is broken into partition, right, each partition naturally will contain information about the files in it, and to use such a partition, you will have to give a mount command kind of thing, which will tell you that what particular partition you want to use, okay? Now, a partition may be, okay, such that it is contained in one particular disk. That means a particular disk, a disk may contain more than one partition, or a partition may encompass, okay, and cover more than one disk, right? Therefore, the partitions can be contained within a disk. In such case, a disk contains more than one partition, or it may be such that a partition covers more than one disk, okay? In that case, naturally, the file system takes care of it, that from which particular disks, okay, a particular file or information has to be retrieved and given to the user, okay? That's all so far as the file systems is concerned. Here we have given the logical view of the file systems as the user views it, okay? In the next lecture, we'll see how such file systems are implemented.